Hello YouTube viewers. This particular lecture is a continuation. I have in lecture number 7 I pretty much explained everything there was in regards to inheritance using abstract classes, inheriting more than one class from another class. That's where we saw that big example. So this is a lighter weight lecture, if you want to call it that, and it gets into the concept of containers and the Java utilities. So in the old days, C and C++ programmers had to put together their own lists, queues, their own data structures, essentially, that included the functionality for, like, let's say, a linked list and stuff like that. Now, Java people have a lot easier. And I'm going to start out by showing you the list example, and then you'll see, as I go through this, how user-friendly the java.util is actually. So you have to import the java.util.asterisk, and in here I've created a class called list example, and let's ignore the suppressed warnings for right now. I'll show you what that means in a few minutes. But moving right along to main, I just put it all into one class. In fact, it's a fairly small class when you look at it. And what we're looking at here is the creation of a list. And you might be wondering, well, where did that come from? Well, we have ArrayList. That's part of this package. So java.util gives us containers for list, for iterators, for comparators, for all sorts of different built-in data structures in the language. So instead of actually having to create a list by concept, we have an object that we can use. And the best way to learn about the util is just to do a Google search on java.util and see what comes up, and you'll see all the different types of structures that you can create and look at, use. But let's demonstrate the array list that's built in for us. And so main here is creating a new list. So list is the object type, and we're going to call it list equals new array list. So C++ people are looking at this going, well, where did you create this array list? It's built in. So that's one of the benefits you have for using Java versus C++ right now. And then we add a list.add. So this method in here adds an item to the list. So we have 1, 2, 3, 4. You can probably figure that out. And then here we have a system out, print the list. In fact, let me add something here. Say my list. Let's put that on there so we can kind of see what it looks like, and we can tell where that line is in the output. And then system out print 2, item number 2, get 2. So now we have add. Now to add an item in, now we're seeing get as a method to go ahead and fetch items. So list.get2, list.get0. So get, and this is an array list. It starts with 0. And so actually, this, if we want, let's go here. This would be 0 actually. This would be the item number. If I spelled that right, 0. We got here 1. We got here 2. And these are just names. 3. Let's go here 4. There we go. Because the array list does start out with 0. So list number 0 is going to give us 0. It's going to print 0 out. And list number 2, 0, 1, 2. It should print number 2 out. But we'll see what it looks like. And the next part, we're actually going to create a queue. So we don't know what a list is. It's an ordered list, an array list. It has index values. And here's our index values associated with numbers we're adding to it. And we're keeping a sequential kind of list. With a queue, we can do things like first in, first out, last in, last out, first in, last out, and different combinations. And what we're doing is we're actually creating a linked list, so all items know about each other. If you don't know what a linked list is, go online, look up data structures linked list. It's a classic structure that we would normally have to create in C or C++ manually. But here we can just create one, and we're going to call it queue because what we're going to use it as a queue. So a queue is, kind of different than a stack. A queue, you think about the grocery store when you get in line to check out at a grocery store, you get into a queue, or you go to the bank to go to a bank teller, you get into a queue. And so the first person in the queue ends up being the first person in line, the second person ends up being the second person, the third person, the fourth person. And so that's a first in, first out queue, because the first person in line is the first person who usually gets helped. You could have queues like or first in, last out, where you pull people off the opposite ends. Like everybody lines up all at once, and you pull the last person off, and you help that person first. Wouldn't really be fair. So queues actually usually run in a first in, first out kind of format. And this would be in comparison to what would be called a stack. A stack data structure is, if you think about loading a stack of plates in a kitchen cabinet, the first one you put down right usually on the cabinet itself. Let's say it's an empty cabinet, you're going to load it up with some plates. So the first one that you're putting in is usually the last one you're going to take out, because you're going to put another plate on top of it, and then another plate on top of it, and another plate on top of it. And when you go to the cabinet to pull a plate out, normally you pick the one up on the top. And that would be an example of the first in, last out. And it's actually referred to as a stack. And this is just terminology that you should be familiar with if you're going to get into this, if you're going to get into programming. And, you know, if you're a computer science student, you heard about this already. You covered this in your data structures or your algorithms course. And in the old days, we had to create these structures. We had to create a queue on our own. We had to create a stack and all of these lists, items, and collections and things. Now the Java programming language, it's already built in for us. It's just in java.util. All right, so let's create a queue. Going back to the example, so I have a linked list. Queue is equal to new linked list, which means we're actually going to create a linked list. And different from a list, an array list. An array list keeps things by index, so we can get items by their index number. A linked list, we usually refer to as pulling something on and taking something off, putting something on and taking something off. So we add to the first or we add to the last, we remove from the first or we remove from the last. So I go back to kind of thinking about getting in line at the bank or putting plates in a cabinet. We're going to pull them off in a different order than we put them on, or we might take them off in the same order, but we're pulling things off and putting things on. And we really only have two ends. We have the start of it and the end of it, or the first and the last item in the queue. So here we have queue.addFirst. So we're going to add a first item to the queue, and here we'll just call it first. Well, first. Well, there's not really first. Actually, maybe I'll leave it back to 6. So we can see the items, the order in which they were added in: 6, 7, 8, 9, 10, which kind of represents the order in which you know, adding to the first, adding to the first, adding to the first. So imagine a line of people, and you're putting people in front of the first person in line. So that original first person in line, in this case, would be 1, 2, 3, 4, 5. 5 people behind. It would be the 6th person in line instead of the first person, because we're adding it to the front. If we're taking off the back, that would be more fair, because the 6th person is going to get out a lot easier than the 10th person, a lot faster, so it would be more fair that way. All right, the rest of this code is going to print out the queue, and here we'll add a comment here. Says my queue, so we know what's being printed out. QUE, UE, there we go. All right, so a little bit more explanation to it, and then we're going to remove an item. So we're going to remove the last item, because we're adding it to the front, so we're going to move from the back. That's like taking number 6, which used to be number 1, so it's fair. And then now we're going to print out the queue after we removed 2 items. So I'm going to put here after 2 last removed. Makes it a little bit more explanatory there. Okay, good. So I'm going to save it, and let's run it and see what kind of output we get. So let's see. I'm going to run it. And this is Eclipse if you're not familiar with this interface. And then so now on the bottom here, I've got the output that I was hopefully looking for. Oh, good. See, my 2 is 2 and my 0 is 0. So going back up to the code, I just went through it actually just a few minutes ago. But my list here is my list here, right up here, and this is my list, which was 0, 1, 2, 3, 4. So it's an ordered list, this array list, and it's ordered by these index values. And number 2, if I got the value that was get 2 from my index, that's actually 2. So 0, 1, 2. This is the item here, and then 0, 0. So that makes hopefully makes logical sense to you. And then the linked list Q is equal to a new linked list over here. We went through it, and I did 6, 7, 8, 9, 10, and then we printed it out, and 6, 7, 8, 9, oops, I misspelled 8, I think. That's okay. E, G, H, H, T. There you go. So that doesn't really matter, I guess. If I print out the Q, we see it's first in was 6, second in was 7. The order is reversed because it's adding to the top of the list. So it's adding to the first element. So we could switch it around and add to the last if we wanted to as well. But this method is adding to the first. You can go online, take a look at the data structure, and see what methods are available to you. You'll be surprised how many there are. So we're printing out the Q. And then down here on the bottom we got remove the last. So it's going to remove the last item, which was really the first item that we put in. So after the 2 last are removed, we have 10, 9, and 8 left over, so which is going to be 10, 9, and 8, which is, after we remove the last 2. So removing last takes it at the end. So we're adding to the front, so it removes it from the end. So this kind of gives you hopefully a little better explanation about how this particular data structure works. And that is what's meant by an array list and also by a queue. And you can implement a stack just by changing the logic around as well. So that was the list example, and you can go ahead and, oh yeah, let me show you about this error up here. If I take this out here, and this is a suppress a warning, and the warning is that we've unchecked the data types. Here I just said list, but I don't know if we're putting in numbers or characters. As an example, I could make the list with numbers and go, let's say 1, 2, say 3. Oops, that was supposed to be 3. 4, 5, and what I've got going on here now is I'm really not doing any checking on it at all. So I save this sucker here and compile it. Let's clear this out here and run it so we can get some fresh input. And let's see. Oops, way down here on the bottom. Run as an application. And lo and behold, I get a new list here. My list is 1, 2, 3, 4, 5, and those are actually, this is interesting, 3 and 1. 1, 2, 3. Well, that's because I started with 1. If I had my numbering correct, I'd start with 0 actually. And then I'd have this numbering lined up correctly because 0 is really 1 and 2 is really 3. Which is actually kind of a classic problem people have with arrays, not starting with 0. But you might have noticed that I used numbers instead. This is a very polymorphic type of utility. In fact, all of the utilities here in the java.util, the data structures that we're looking at here in terms of lists, array lists, linked lists, all sorts of, you could put numbers in there, characters in there, but what you can't do is this. You can't go like this and say, one's a number, the other one's a string. Well, actually, good question. Can you do that? I don't believe you can. I think it should give you an error message, but no error message, which is interesting. I might be proven wrong on video. I am proven wrong. However, we're not really using it as a string or a number, so I guess it doesn't really matter. But theoretically, you're storing a list of numbers, you're storing a list of strings, you're storing a list of doubles. They should all be hopefully of the same type, but as you've just seen, I can put a piece of text in there. Actually, let's go like this and go here, Barb. Let's see how. I'm kind of shocked that it works actually. Let's see. Yep, it works. So we can mix and match data types, which I have just proven is different than, well, it's kind of breaking the rules, because if you're using a list and you're going to sort it, that might actually be an issue, because where would Barb show up? I guess it would take, if you're sorting numbers by numerical order, Barb might not show up correctly in the list. But theoretically, because we are suppressing warnings and anything, and we're not really doing anything here that would cause a warning, we can sort of get away with that. If we took out this here, suppression of the warnings, and this is simply an Eclipse thing. Now we're going to get some data type issues. In fact, it's going to go in here and say ArrayList is a raw type. because we're using a generic raw type. And it should be parameterized. So the list is raw type, so we would reference a data type in there. So what we can do is infer a generic type argument or add type arguments to list. If we infer a generic type argument and we apply it to all of the different elements here, oh, here we go. We have a comparable as a data type. Hold on a second. Let's go back actually, and I'm going to change this one to let's put the example back with strings. I'll show you because I haven't explained the comparable yet. Let's see. What I wanted to do is actually get a real data type that you're familiar with to show up. Let's see. All right, now let's take this away. If we take away this, and what we're doing is it's not really type casting, it's explicitly declaring a type that's going to show up for that. Okay, all right, so now we have strings in here. So now if I kind of go through this process, what I'm looking for, and this is kind of an interesting thing that happens with Eclipse, is these little buttons show up. So now if I infer a generic type argument, and I pick one that's going to meet for all of them, there we go, that's the behavior I was looking for. It'll actually say, this list is a string list. I could have gone like, let's say string list, and then list. Oops, this is a list with a capital L. Well, actually, no. Actually, because that's a string variable, that's not going to do the same. No. There's really no other way to do it outside of specifically stating the data type. And if we do that, then we're saying that the list is going to be, this list data is going to be a string list. And we're going to use an array list, string array list, which is kind of an explicit way of declaring the type. You only do that when you create the structure. So down here we have a linked list. We're also using strings down here. It would put an integer, float, double, whatever it is that was, as this is the Eclipse kind of tool that's going to be doing that for you in terms of the error checking. Regular old Notepad, you're going to have to do it manually yourself. In fact, regular old Notepad, you may not even get an error message. In fact, that wasn't an error message, it was a warning that showed up. The program probably would have compiled just fine. In fact, if I take this out and look at it, I don't actually see an error message. So if I saved it and compiled it, this is a warning message. I should have a fully functioning program, and I do. So with the right output. So it's really just a warning. It may just be an Eclipse related thing as well. All right, so that was an elaboration on the list example, and let's move on and let's take a look at the set. Let's take a look at a set versus a list. And this is what the third homework assignment has to deal with, because you're creating a hash set or a hash map. Actually creating a map, I believe, with the third one. Let me clear the output out here too. Clear. Okay, so this one deals with a set, and so we're looking here at a set example, and I just explained this suppress warning, so hopefully you know what I'm talking about with that. I can leave it in, but it looks kind of ugly. That actually looks kind of hard to read, I think. I don't know. So I'm going to add the suppress warning to the list. Oops, and now I'm going to actually have to add the other one too. Hold on. There we go. Alright, perfect. So now I don't have all the yellow stuff going on. In fact, these can actually be added together. In fact, we can go right here. And it's basically just telling us that we're using raw types that it doesn't really like. Maybe that should be a comma in there. Maybe not. There's a comma. Alright. But anyway, let's leave that one alone for now. Let's not say the... Okay. Okay, so it looks like a set versus a list. What is a set? A set doesn't really have an order to it. It is, is the item in the set or is the item out of the set? In terms of the set concept, we have a hash set that comes from Java, or in the java.util. And in terms of the hash set, here we've got set equals my hash set. And we create a hash set. It's kind of an efficient way of creating kind of just a grouping is what we're looking at. So set.add1, add2, add3, add4, and it's just a set. There's no particular order to it. And so now we can say, is something in the group, is something in the set, is something out of the set, and we can take the set and print the set out. Here's the set being printed out, so we can say our set. We can print a set out. The set, we can create a sorted set, and let's call this a tree set. That's going to create a data structure out of it that's going to be a sorted tree configuration. So let's give it our tree set. Our tree set. There we go. And it just makes it a little more interesting. Makes the output a little bit more interesting. So, okay, I'm going to save this one, and if I run this, and I will see my output. I have one set, which is interesting. Our set has 2, 1, 3, 5, 4. 2, 1, 3, 5, 4. Not necessarily the order we put it in, which means it's not ordered. It's showing you that it's just a hash set that's been put together and been optimized for sorting and searching and stuff like that. And then our tree, we've got 5, 4, 1, 3, 2. It's set. We can't really see the physical tree, but it's ordered in terms of its hashing, so it's a sorted set for searching. But not that exciting. It's just the concept of creating the set. And go online and kind of read about set concepts. And you'll see what the data, and this is not really a data structures course, it's more of a Java programming course, so I'm not going to really teach you a lot about the data structure. I'd rather have you just know how to create them, and then figure out what you want to need by looking up examples, and to figure out what data structure might be good for you. Let's look at a linked list example. It's kind of an extension of the list. Lists are a little bit more interesting, I think. This one I did not suppress the warnings. In fact, I just left the information in there. And this one's interesting because it actually does and it demonstrates three concepts. The linked list as a, and here you might notice I used java.util instead of going asterisk or asterisk on there. You noticed in this particular one we have the asterisk here. This one here is taking specifically all three of these and nothing else. So just these three. And making use of these structures. So here we have the linked list. It's going to be an integer linked list. And I know the LL is kind of hard to see, but it stands for linked list. The old days, a linked list was kind of a list that had nodes in it. And the node had a head and a tail. And we added items to the list. And we changed the next to point to the next item. There was an old joke that went around, you know, the linked list is only as strong as its weakest link, and as soon as you lost the link, you lost the data structure, which is kind of the theory of the linked list. We have pieces of memory, we have items stored out there. We can change the order around, and it's a lot more efficient than if we created, let's say, an ArrayList or one of the other structures. This is just like using pointers, but we don't have pointers in Java. But instead we can kind of play around with it as a structure, and we can have methods in there to add, remove, delete, and stuff like that. So here we have the linked list integer. This should look familiar. And we're creating a linked list of an integer type, explicitly specifying that because I don't have the warning message here. And if I left it out, it would look alright as well. It would work just fine. Meaning if I left this stuff out. We're just going to get a bunch of warning messages. It messes up my display. I like this look better. Okay, so we have linked list.add, -8, 20, -28. And then we have a comparator R for the collection. And here we have the collection.reverse order. So we're going to reverse order, and we're using a collections.sort here. So if we create a selection, if we create a linked list, put it in a collection, and then we can sort it, and then we can compare, and we can do all sorts of different things with it in terms of a data structure, using it all together. And this is really the theme of that third assignment, if you're taking the object-oriented Java class that I'm currently teaching. Otherwise, this is just information for you, but you can just ignore that. Here we're going to list sorted in reverse. We can put a, let's say for I, for the entire linked list. We can print out I plus, and print out each one of the items in the linked list in a sorted, in reverse order, because we're loading the collection here, and we're sorting the collection as a reversed order collection. We're using the linked list in terms of calling a sort on it. So we could take these items, apply it to another structure to sort the collection in reverse order. So the reverse order that it came in. So we're going to print it out. Actually here, okay, yeah, we have the title here, list that is sorted in reverse, and it's going to print out the list. And then we have a line here. And then we're going to shuffle. We're going to go collections.shuffle. So this is kind of telling you on the collection, we can run these methods like sorting it, shuffling it, reversing it. There's not too many things left on it. If we do that, we're basically doing the same process again, running a for loop to shortcut, kind of unconventional kind of way of doing it. Which is, well, I shouldn't say unconventional, it's very conventional for this approach that we're looking at. And then we can say out of the collection, give us the minimum value, give us the maximum value here on the bottom. So the minimum value is this, the maximum value is that. So this is showing us the collection comparator, which is a way of comparing one value to another. And it's a linked list. So we threw this linked list into a collection. We're running methods on the collection as an object, the linked list object as a collection object, and then we're using a comparator on there to do some things like finding values and sorting things and looking and comparing one item to another. If you want to think of it that way. So I'm going to save this just in case I made any changes on it. And when I run it, I am hopefully going to see some nice output on the bottom here. And the nice output that I'm seeing is the list sorted in reverse order. Well, the reverse order, let's see, the shuffling. If we ran this five times or so, we would see some shuffling. The reverse order, it's kind of random. And let's see, how did we put that in? The linked list. I'm kind of questioning this reverse order. You know why? Actually, no, it's by value, so it's big to small instead of small to big. I got it. I have to remember my integers for a second here. -8 is bigger than -20. Okay. All right, and then shuffling up. In fact, so it's taking the numeric order and it's reversing it from 1 to 10 to 10 to 1. And so in the shuffling, what we're doing is we're just randomly giving you numbers out of this collection. So you can use this for like game programs where you select a card and it pulls out a random card out of a 52 card deck or something. Shuffle it up, move the cards around, so it provides some chance or something. And then obviously the minimum and the maximum values here. Coming from the minimum and maximum methods down here that we're running, the min and max on the collection. So hopefully that gives you sort of an orientation to the collection concept in terms of, and also another example about a linked list. That's really not an array list. This one here is the array list, slightly different than the linked list example. All right, let's take a look at, I've got the iterator example here. Why do I have two of them in here? Linked list example. Let me see. Interesting. Maybe I loaded them in different packages. Okay, this is the one I think I want it next. Yes, this is the one I want next. All right, let's go back to our array list. Although we can do this on anything we want. We're going to create an array list. And this example is going to show the iterator as the point being. And this is another way of using a collection. Is to iterate. And let's see what that actually means. So I'm going to suppress the warnings here. We've seen that already. Don't worry about that. All right. It just basically makes my display look better. Okay, so in our main, we're going to create an array. So ArrayList AL for ArrayList. I know, very extremely creative. Equals new ArrayList. Add elements to the array. And the array elements that we're adding is C, A, E, B, D, E. I know, just add in some characters. And this is a string array list because we're using the double quotes here. Use the iterator to display the contents. Now you're wondering, well, what does an iterator do? Well, it goes through and if you think of the concept of what the list is doing, it's on a current item. Well, it knows the first, it knows the last, it knows the current item, and then it just goes to the next item, to the next item, to the next item. So here we have a system out original contents. Here we're going to print out the original contents of the array. So iterator, ITR, the name of our fancy iterator, I know, another creative concept, equals ArrayList al.iterator. So call the method to create an iterator on the object that is of type ArrayList that is called AL for ArrayList short. So while the iterator has next, so this has next method says, are there any other items in there? Has next, has next, has next. If it does, we have an object element equals, and we're just creating just basically a generic object. And say the next object, the object element, everything in Java is inherited from object. All objects come from the object class. So we can use object because it represents every element, if you think about it. Object element, and maybe I should, I think I actually already covered that in one of the previous examples, or previous tutorials. I was thinking maybe I should come up with an object tutorial, but I think I beat that one to death in the previous tutorials or so. Alright, so object element equals itr.next. I mean, get the next. System out. Let's just print out the element and put a space in between each and one of them. So this iterator is doing is being performed in this while loop here. The while loop, it's kind of like the old days, we went through an array, or used for a while loop. Actually, you probably used a for loop in an array, common array, to print out, while 0 to 10, print out array element 0, 1, 2, 3, 4, 5, all the way up. We don't have to do that. Instead, we can just create an iterator, does it have a next? While it has a next, then print out the next. Get the next, copy it to this element object, print out the element object. We could have probably just saved a step as well and just printed out the next as well, but wouldn't make it as clear. Okay, so we're going to put a blank line in here. Now we're going to modify the objects that are being iterated. So we have the list iterator is like ArrayList.list iterator. So now we're going to use a list iterator to modify the items instead of just iterating them. We're going to modify them. So what we have here is another while loop where we're going to say, well, while it has items, while the list iterator has items, then the object element is the next one. This is the same as above here. And then print out the elements. And instead what we're using here is the list iterator, which is going to actually modify. So after we get done with this concept here, we can print out the modified contents of the array list by saying that the iterator equals ArrayList.iterator while we have elements, print out the iterator next. And so we have essentially taken the list iterator and used that particular method as an example, modified the contents of it, and printed those out, and then displaying the list backwards. Let's say, for example, we can take modified list backwards, has previous, and so instead of saying has next, we're going to go has previous, and what we're seriously looking at here is just a bunch of loops, and the way that we're going through them is either printing them out in order, modifying the order, or as an example, printing it out backwards instead of forwards. So let's take a look. Hopefully, let me clear this out. Actually, hopefully this will compile. And I haven't. As I'm typing, as I'm pressing and clicking here and there, I accidentally make changes and stuff. So I was curious if things will compile. Yep, they will. So the original contents of the list had C, A, E, B, D, F. We didn't play with the contents of the list. Instead, we modified the contents of the list to add a plus next to it. And the way we did that is right here, actually. In terms of the, when we had the list iterator, instead of the iterator, we took it and we set, I forgot to go over this actually. I knew I was forgetting something. we set the element to something. So list iterator that modifies it, an iterator is just going to go through and it's just going to give you what you've got. The list iterator is going to be a variation of that. When we're looking at the difference between this type of object and this type of object. This type of object is generic, you can't change the list. This type of object allows you to go through, and in this particular example we added a plus next to each one of the items, and we set the list item to dot set element plus something, which is now I remember why we have element in here, because we needed to take that and, instead of just printing it out, take it and add it to one, or add a plus to it and print it out, which gives us a little bit more flexibility. So our modified list has the plus next to it, and then our list printed in backward orders is the same list. It just reversed the order, so it has previous instead of has next, and we did pretty much the same thing. We didn't modify it, so we just printed it out. Here we have element plus a space instead of element plus a plus sign and then a space. So we can pretty much see how that comes together. So it kind of gives you an example of iteration. And up here we could have just, well actually we used all three. We could have put in the same type of imports. But normally you're going to see it more like this. You're going to see java.util ** instead, because it's a bit clearer. So I mean, it's a little easier to understand than having to list them all out. Plus you don't know what you're going to use. So I believe I've actually covered all of the list examples that I had put together. I believe these are just copies. It is possible that when I loaded them in, I loaded them in twice, which definitely looks like case, or I put them in a different package or something, because that looks like it's in the default package and these aren't. So, in any case, that is my spiel on collections, iterators, linked lists, array lists, and all the built-in functionality. Don't reinvent the wheel. The last thing you're going to do is create a class called LinkedList. You're going to use what's built in. So I highly encourage you to go out and see what is built in and see what you can use in terms of these structures here. So we have ArrayList. We have the ability to create all sorts of different things, including hashes and maps and all sorts of functions. So experiment, and I'll see you back next time for a new topic. Thanks for watching.